Hi, I welcome you all for this session. In this session, we are going to see the topic ARM architecture and its versions. As you see, these are some of the popular companies which manufactures the ARM board. Analog Devices, you can see it here, Microchip, Cypress Semiconductors, and STM, manufacturers of Cortex, and Texas Instruments, TI processors, and we are using Keil software, NXP Philips Semiconductors, and Maxim Integrated Company. So these are the companies which are in popular of manufacturing ARM boards. So before getting to the topic, we can have a refresh discussion on computer architecture. Basically, we have two types of architecture. One is von Neumann and another one is hardware architecture. In von Neumann, you have same address and data memory in a single block, whereas here in hardware architecture, you have separate memories for data and program. So this is the basic difference between von Neumann and hardware architecture. Each has its own advantages. In the coming slides, you can see the versions of ARM architecture. So in that versions, some ARM architecture uses von Neumann architecture and some uses hardware architecture too. We will see in the coming slides. Now this one, we should understand the basic differences or the common differences between RISC-based architecture and CISC-based architecture. So von Neumann architectures are based on RISC and hardware architecture are based on CISC. Okay, now what is meant by RISC and what is meant by CISC? So RISC is nothing but reduced instruction set computer, and CISC is called as complex instruction set computer. If you come back to RISC, it uses less number of instructions, whereas in CISC it uses large number of instructions. And RISC is based on software. The instructions are optimized, and in CISC hardware is to be optimized, and RISC has simple decoding of instructions, and CISC has complex decoding of instructions. In the coming slides, we will see the pipelining concept, which has reduced number of instructions for the completion of the program. So because of pipelining concept, RISC has simple decoding of instructions, and here CISC won't apply pipelining because it's dependent on hardware, so it's very difficult. The program written for RISC architecture takes more space in memory, whereas in CISC architecture it takes less space in memory. So this is the notable point, very important point for RISC and CISC. RISC takes more memory space. Even though it takes more memory space, it takes less time to execute the complete instructions, whereas CISC takes longer time to completion of the execution of the instructions. And RISC has fixed format and CISC has variable format. And RISC, it is a hardware unit of programming in the RISC processor, whereas a CISC microprogramming unit in CISC processor. The RISC architecture can be used for high-end applications like telecommunication, image processing, video processing, because we have a lot of M4, Cortex, and more higher-end processors are available with the RISC instruction set. In CISC architecture, it can be used for low-end applications like home automation, security system. So it depends upon your application. So whether it's for home automation or office automation or for CCTV camera or for security system, for lower end applications, right? Wherein we need not to have much more accuracy or speed, we can go for CISC type of architecture. If we need very high-end processing, more data has to be processed, and we need high performance, high accuracy rate. If we need data like that, then we have to use a RISC-based architecture to process all those informations, all those data. So examples of RISC: ARM, AVR, ARC, and the Spark. And examples of CISC: Motorola, AMD processor, and the Intel processors. Right. This is the common difference between RISC and CISC based architecture. Now, what is ARM? ARM. So it is nothing but RISC machine. A stands for advanced, R stands for RISC, and M stands for machine. It was founded by R.M.K company. Later, it was developed by Apple and VLSI. They got copied. They started to manufacture ARM-based processors. It's basically started with 32-bit RISC processor. First RISC is microprocessor. For it is used for commercial purpose. The main point here is to be noted is why we are, it consumes only low power. So this point is very, very important. It consumes only low power. With low power, we are able to go for high applications, high-end applications, and it is also portable. Okay, easy to carry. So that's why commercially it is very successful. So because of low power and portable benefits, now ARM processors are very much used in commercial purposes. Okay, now we can have a look on ARM features, what it consists of. Basically, ARM is nothing but it's a combination of RISC machine idea and load and store concept. Load and store concept. Okay, so ARM boards are designed based on RISC instruction set and also load and store concept. And it also has few more advantages like thumb instructions. Thumb instructions are nothing but it's if ARM board is 32-bit, ARM instructions are 32-bit. Thumb instructions are 16-bit. So we need not to write instruction for 32-bit. We can write instruction which can carry 16-bit also. So this is one advantage. And also pipeline. So pipelining concept is also one more advantage. We will see in the coming slides what is meant by pipelining, what are the stages in ARM, what are the pipelining stages in ARM-based boards, right? And see, other advantages are it has a good frequency power ratio. It covers a wide range of frequency. It can be used for Java developers. Java developers also can use this RISC processors. built-in debugger facilities available, and we can also carry the DSP applications, speech processing. So these are some of the features, uh, ARM features, which is the combinations of RISC as well as load and store, thumb instruction, pipelining concept, and a few other features. So it's very that's why it is very famous to use as commercial processors, right? As I said, reduced instruction set architecture, load and store type architecture is used. So 32-bit can be splitted into 16-bit as thumb instruction set, and it also supports pipelining to speed the flow of instructions for good performance. Now, what is meant by pipeline? See here, in the first cycle, fetching of instruction is done, and in the second cycle, the fetched instructions are decoded and new instructions are being fetched, the cycle 2. And in the third cycle, the decoded instructions are now executed, the fetched instructions are now getting decoded, and new instructions are being fetched. So in the third cycle, 3 instructions are happening, right? Like fetching, decoding, and executing. This is known as pipeline. So within 3 cycle, you can complete this fetching, decoding, and execution. It is 3-stage pipelining. Fetch loads an instruction from memory. Decode identifies the instruction to be executed. Execute process the instruction and writes the result back to the register. By overlapping the above stages of execution of different instructions, the speed of execution is increased. So this is the concept of pipelining, which allows the ARM core to execute an instruction every cycle, which results in increased throughput. See here now you have 5 stages. Okay, so fetch, decode, execute, memory, and write. So 7 stages is also available. So these are the enhanced versions of RISC ARM processor. Basically, we have 3 architecture profiles: A, R, and M. A for applications, R for real-time, and M for microcontroller. As you can see here, the application ARM processors are used for high performance and to run on complex operating system Linux. And the real-time processors, ARM processors, are targeted to work with real-time requirements like networking, controlling, embedded controllers, and microcontroller. This is the basic profile. It's a small but power efficient devices. Okay. So with low power, it can effectively show its performance. Many of the IoT applications which uses sensors, actuators, which works at low power value. Okay, it consumes only low power, but it can work at it can give it can work with sensors, actuators, controllers, real-time data handling, everything. All this setup will comes under IoT devices. So now let us see about versions. In the first version, we don't have multiply and coprocessor. It's just a simple addition and subtraction. And in the second version, which is commercially launched, which supports multiply instructions. And in the third version, one more enhancement is done to load and store, and also to cache management, to temporary storage of data, and to load and store of the processed data. And in the version 3, you have virtual memory support, which has 32-bit addressing. And you can see the comparison table of ARM 7, ARM 9, ARM 10, and ARM 11. So for ARM 7, the pipeline is 3-stage. For ARM 9, pipeline is 5-stage. and 10 is 6 stage, 11 is 8 stages. And if you see the operating frequency, it's very important. For ARM7 80, ARM9 150, ARM10 260, ARM11 335. And see the power consumption. So 0.06 milliwatt is consumed by ARM7, very low. And this is 0.19 for ARM9 power consumption. And ARM10 is 0.5 milliwatt. And ARM11 is 0.4 milliwatt. So with low power consumption, you have to get the fast, high throughput. And this is the instruction per set. So how much fast instructions can be processed, fetched, decoded, and executed. So this is the megahertz frequency at which the instruction can be processed. Okay, so several it's depend upon the board, ARM7, ARM9. It is mentioned here, right? And then, as I said, ARM7 is based on one human architecture, ARM9 hardware, ARM10 hardware, and ARM11 hardware. So it depends upon the application. So the application needs a very good architecture so that the desired output or speed, performance, controlling, whatever requirement is needed, we have to choose the particular type of architecture. And for multipliers are used for this SOP operations. See here, it's 8 cross 32 ARM7, ARM9 also 8 cross 32, ARM10 and ARM11 16 cross 32 and 16 cross 32. Okay, so this ARM10, ARM11 comes under MC3, MC4 Cortex development boards. So this is the table which gives the ARM family comparison. And in summary, we have seen computer architecture, basically two types, one human and hardware. And we understand what are the difference between one human and hardware architecture. And we discussed the advantages and differences of RISC and CISC. And we also uh, understand the features of ARM, how ARM is developed and why ARM is needed. That is for low power consumption, load and store, pipelining, and also we studied the 5-stage and 7-stage pipelining concept. And we just now discussed about ARM versions, version 1, 2, 3, how we developed, what are the differences in the ARM versions. That's all about in this video. We will see in the next video. Thank you.